This is May 2015, Paper 2, Time Zone 2, question number 7. And it's a question about where do graphs cross. We've got the graph of f of x, which is a quadratic, and the graph of g of x, which is linear. Now, the easiest way to do this is not to think about the graphs, but to think about the equations. Say, if they're crossing at two distinct points, then that must mean that there must be two values of x for where the f of x is equal to g of x. Well, that's a quadratic equation. So all I have to do is rearrange that. So it's equal to 0, and I'm going to get kx squared plus kx minus x from the left plus 0.8 is equal to 0. And the question is, when will that have two distinct points? i.e., when does this equation have two real solutions? So this is really a question, it's not really a question about graphs, it's really a question about the discriminant. When does a quadratic equation have two real solutions? It has two real solutions if b squared minus 4ac is greater than 0. And in this case, what's a, what's b, and what's c? Well, a is just this coefficient here. So a is k. B is the coefficient of x. If you took x out as a factor there, you would get k minus 1 times x. So b is equal to k minus 1. And then our c is just the last number. You have to watch out for the signs sometimes, but not a big deal in this case because c is positive, c is 0.8. So we're going to substitute those into the inequality here, into this inequality, and we're going to get b squared, so that's k minus 1 squared, k minus 1 squared minus 4 times k times 0.8 is equal, so not equal, has to be bigger than 0, greater than 0. That's the inequality we're solving. This bit here, 4 times 0.8 is 3.2, so that becomes minus 3.2k. And the other bit, this squared out a million brackets by this point in the course, squares to x squared minus 2k plus 1. So if we just collect those together a little bit, we're going to get k squared minus 2k minus 3.2k is minus 5.2k plus 1 is greater than 0. And now this is the point where I've got an equation that I can plot. This is going to be a parabola, a U-shaped parabola. I could solve it algebraically probably, I don't know how nice those solutions are going to be, or I can just get my calculator to graph it for me and figure out where is that graph bigger than 0. So I'm going to type into the graphing calculator x squared minus 5.2x plus 1 is greater than 0, and this is what will happen. That's what it looks like once I've typed it in. The graph that you get looks like that. And you can see that there are two intersections. And where it's bigger than 0 is this section here and this section here. So I just need to find the values of the intercepts, which is in the calc menu under 0. And if you do that, your calculator will tell you that the 1 is at x is 0.2. So k is 0.2. So this point here, where it crosses close to the axis, is k is 0.2. And the other one is at 5. Which means when is this curve bigger than 0? Well, it's bigger than 0 if k is smaller than 0.2 or k is bigger than 5. So they're the points where we have to have two solutions. And I think there might be one more caveat. So there's one other thing I'll need you to understand, which is that these will only cross twice if f of x is a parabola. So f of x must be a parabola, which it will be for nearly every value of x, for nearly every value of k, except k can't be 0. If k was 0, then that would mean that f of x is also 0. And then we'd just have two straight lines, f of x, which would look like this, and g of x, which would be up there somewhere, and they would cross at this point here, only once. So as well as the deductions I made before, that k is less than 0.2 and k is greater than 5, k can't be equal to 0. And the last thing I want to point out is that these must be strict inequalities, because if we allowed equal to 0.2, we would have exactly one solution. So that's the final answer there. K is less than 0.2, more than 5, and not equal to 0.